Welcome to my YouTube channel, A Brain Area of Civil.
So in this lecture, I am going to analyze the problems of 6th assignment of Foundation Engineering. So the first question is, which of the following pile is driven at an angle and can carry a large horizontal load? So coming to first option, batter pile. So batter pile is the pile, it can carry horizontal or inclined loads. Even during provision of batter pile, we can provide certain inclination for the pile. Okay, so actually for the question, answer itself is batter pile. And coming to tension pile, it will be subjected to type of loads called tensile loads. Okay, and coming to friction pile, because of skin friction, the loads can be carried. And coming to under-reamed piles, under-reamed piles are the piles, they can be provided in cohesive soils at somewhere certain distance from the ground. There is formation of bulb. Okay, so these bulbs are provided to provide the effective cohesion between this material of pile and the soil. Okay, so here inclination to the pile can be provided in batter types of piles. Option A for question number 1. Second question, what is the diameter of under-reamed portion of under-reamed piles? Obviously, it is a battered pile, under-reamed pile. So if the diameter of is D, during bulb portion, the diameter of under-reamed will be is equal to 2 to 3 times the diameter of the main pile. Okay, so the option D for question number 2. Coming to question number 3, so he has given a rectangular footing and unit weight of the soil and load is given. So he has given certain inclination and eccentricity and cohesion and angle of internal friction, and this is a direct formula, you can go through it. So you will get a factor of safety 2.5. Coming to next question, match the following. So end bearing pile. So this end bearing pile can transmit the load through weak soil to hard stratum. End bearing pile is, for example, if I take a pile, surrounding soil is very weak and this bottom portion is very hard. So that is, whenever there is a weak soil, we need to transfer the load from this weak soil to far depth. So below the far depth, we need to maintain, it is required to be provided the hard stratum. Okay, so end bearing pile can transmit loads through hard stratum. Okay, so for option 1, D will be matched. And under-reamed piles, I already told under-reamed piles can be used in expansive soils. Coming to friction piles are the piles which can resist the load through sides of the surface, that is skin friction between embedded soil, that is surrounding soil which is present beside the pile. Okay, so this is friction pile is. And precast and pre-tensioned piles are used in marine environment, because in marine environment it is required to provide the company manufactured, industry manufactured piles. These type of piles we call it is precast concrete piles. So it will be A. So for this question, answer will become D. Coming to question number 5, a 15 meter long 250 mm diameter pile was driven, uniform sand, phi is equal to 29 degrees. The water table is at great depth, that is there is no effect of water table. The average unit weight of the soil is 18.5 kilonewton per meter cube. Calculate the ultimate skin friction resistance of the pile. Delta value K. So first of all, he has given it is pi is equal to 29 degrees. Delta is equal to 0.75 into 29. So you will get it is 21.75. And skin friction QF is equal to K sigma V tan delta. and surface area. So K is equal to 1. We'll calculate sigma V is equal to, so the length of the file is 15 and 18.5. So you will get it is 277.5. So 1 into 277.5 into tan 21.75 into surface area is, perimeter is pi d and throughout the length pi dl. So pi, diameter is 0.25, L is equal to 15 meters. So you will get it is 1364 around. So the maximum value is A. Option A for question number 5. Coming to next question, a 20 meter long 300 mm dia pile was driven in a dense sand. So that is pi is equal to 40 degrees. Determine the critical depth of pile. Critical depth of pile is 20 times diameter of the pile in dense sand and 15 times diameter of the pile in loose sand. So here 20 into diameter will become 0.3. It is 6 meters. So option C for question number 6. Coming to question number 7. Calculate net ultimate bearing capacity of a strip footing. So we have a formula, net ultimate bearing capacity of a strip footing. QNU is equal to CNC gamma D NQ minus 1 plus 0.5 gamma B N gamma. So C value he has given as 20, NC is 95.7, gamma is equal to 19 into D is equal to 1.5, 81.3 minus 1 plus 0.5, gamma B is, so it is 19 minus 10, because he mentioned the water table is laid at the base of the footing. So we need to consider submerged unit weight below the base of the footing and saturated unit weight above the base of the footing. So now into 2 into 100.4, it will be 5106.15. You will get answer A for question number 7. Coming to question number 8, he has given a rectangular footing. So for this rectangular footing, net ultimate bearing capacity formula by IS code is QNU is equal to 1 plus 0.3 B by L into CNC plus gamma D NQ minus 1 plus 1 minus 0.2 B by L 0.5 gamma B N gamma. So the only new terms were added to the earlier formula is this and this. Remaining is same as usual, strip footing. By substituting all the values given in this, you will get around the value is 570. The nearest option is answer A. Okay. So for question number 8, answer A. Coming to question number 9, which of the pile is most frequently used in all loading conditions? Generally in all loading conditions, we use concrete pile. Okay. Coming to last question. The bored piles in sand have point bearing resistance of driven piles. He has given point bearing resistance in bored piles and point bearing resistance in driven piles. The point bearing resistance in bored pile is generally half of the point bearing resistance in driven piles. He has given it is half to 1/3. So the answer D for question number 10. Thank you.